Okay, what's up, class? We're going to be dividing rational expressions in this video, and then we're going to look at how to solve rational equations. So let's go. So for this problem, we have two rational expressions that involve division. So what we're going to do when you divide fractions, just like you would with just numbers, you are going to flip and multiply. So we're going to take this original and we're going to flip the numerator and the denominator. So we have 8x squared on the top minus 28x plus 12, and then in the denominator I have 4x squared minus 1. Now it's going to be just the same as when we multiply rational expressions. We're going to follow those steps that you wrote down in the last video. First step being we have to factor everything. So this is a trinomial here. And what I'd like you to do right now is stop the video and try factoring each of these numerators and denominators, and then come back. So this will factor into 2x, and if I have a 4 over here, I'm going to end up this is 8 and 1, which will give me my 7. I need this to be a negative and this to be a positive in order to make it a negative 7. The bottom, the denominator here, is a difference of squares, and that's something I've been telling you for a long time now to be watching for. Difference of squares is going to factor into x plus 3 and x minus 3, the square root of x and the square root of 9, plus and minus. Over here, the very first thing you always want to look for when you're factoring, just to make things a little easier, is to look for common factors. And in this numerator on the right, we have a common factor of 4. 4 goes into 8 and 28 and into 12. So I'm going to factor out a 4. And I'm going to rewrite the expression that's left over here. 28 divided by 4 is 7, and then I have plus 3. And then I'm going to still need to factor that trinomial in just a minute. In the denominator here, again, I have a difference of squares. It looks a little bit different than the one on the left, but it's because of the 4 in the front. But it's still going to factor into the square root of 4x squared, which is 2x. And then we're going to go plus or minus the square root of 1, which is 1. Okay, so now let's write this out. I have 2x plus 1, I'm writing this down right here, times x minus 4. Last time we crossed these out as we went, just put still be able to read it, maybe put a line through it just so you know that that's been factored. And then I have a 4, and I'm going to factor this guy right here, which is going to be 2x and x, and then this will be 3. I need a negative 7 and a positive 3. That's going to be minus 1 and minus 3. And that becomes, this is 2x squared if I FOIL it, minus 6x minus 1x will give me that 7, and a negative times a negative will give me plus 3. Okay, and we're going to multiply all these together. I'm kind of combining a couple steps, but you can write it all as a single numerator now, multiplying the numerators together, and as a single denominator. X minus 3, and then I have 2x plus 1, and 2x minus 1. Now, the next step is to simplify this by taking any common factors and crossing them out. Got an x minus 3 and an x minus 3. It has to be in the numerator and the denominator. What else do we have here? We got a 2x minus 1 and a 2x minus 1. It's kind of satisfying. You can cross these guys out. 2x plus 1 and 2x plus 1. I believe that is it. Don't miss anything. We have an x minus 4, and we have a 4. I'm going to bring that 4 in the front. 4 times x minus 4 is left in the numerator. And in the denominator, I have x plus 3. Now take a look and see if there's anything common in the top, in the numerator and the denominator. There are no common factors other than 1, so we are done. But now keep in mind when you're simplifying these that the expression has to match the original expression, but in a simplified form. And in the original expression, we have this is undefined at 3, at negative 3, at positive 3, and we have it's also undefined at negative 1/2 and positive 1/2. And so we have to keep that in mind as we go through this. Okay. Oops, did I miss one? Also undefined, where this expression, the denominator here, is equal to 0, which is at 1/2 and 3, which I think we already hit with the other ones. Okay, let's move into solving rational equations. This just adds an extra step. What we're going to do, we're going to still simplify the numerator and the bottom, the numerator and the denominator, just like we were, and then we'll take the next step from there. So again, this is a difference of squares. This is going to factor into 2x and 2x and plus 3 and minus 3. Now 2x plus 3 is going to simplify. Let me rewrite that. Then left in the numerator I have a 2x minus 3 over 1, which I don't need to write that, equals 5. Now it's a much easier version of the original to solve. We're going to add 3, we're going to add 3, we end up with 2x equals 8, divide by 2, and we end up with x equals 4. Now, a very important step in this process is to check your solution. And the reason for that is because, remember, there's going to be places where the expression is undefined, and that's when the denominator is equal to 0. So if you ever get a solution that makes the denominator equal 0, you got to throw it out, and it doesn't work. It's called an extraneous solution. So plugging this back in, if I check this at x equals 4, in the original I'd have 4 times 4 squared minus 9 divided by 2 times 4 plus 3. All right, 4 times 4 squared is 4 cubed, which is 64, minus 9. And then on the bottom I have 8 plus 3, which is 11. 64 minus 9 is, let's see, 55 over 11, which does indeed equal 5. So we are good. That's the answer. X equals 5. Okay, one more here. We're going to, again, we're going to factor the numerator, factor the denominator. The denominator's already factored, so that's nice. Just have to factor the numerator, and you will see that oftentimes, to help you with the factoring, there's going to be something that's going to simplify. So we probably have x plus 4 as a factor. And we're looking for factors of 12, negative 12, that add to positive 1, which would be x plus 4 and then x minus 3. So we have, we write that, x plus 4 times x minus 3 in the numerator, and then in the denominator I have x plus 4. And keep in mind this is undefined when x equals negative 4, because it would make the denominator equal 0. And the x plus 4 will cross out. X plus 4 over x plus 4 leaves me with x minus 3, and then I have equals negative 7. Add 3 to both sides, and you end up with x equals negative 4. Now, plugging that back in to check our solution, you'll find, okay, negative 4 squared plus negative 4 minus 12 over negative 4 plus 4 equals negative 7. I don't even need to evaluate the numerator because down here I have a 0. It doesn't work. It's undefined at negative 4. Therefore, we're going to eliminate that solution. And what we say is that this has no solution. So always make sure you check your work when you do this. One more pointer that I want to give you is when you guys are simplifying, if you have something like x plus 4, let's say we have plus 5. Oh, this is, hold on, let me pause for a second. Okay, what I want to point out is that when you're simplifying the numerator and the denominator, they have to be factors in order to cross them out. And like a common mistake is students will see, they'll simplify it to here, and then they see this x squared, and they see this x squared, and they want to cross those out, and then maybe even these x's. Cannot do that because x squared is not a factor. X squared is being added to 2x. A factor means that it's getting multiplied. So if it would have been instead, let's say I had something like x squared times x plus 2x, and then in the denominator, now it's a factor because it's x squared times something else, and in the denominator, if I had x squared times x minus 3, Oops. This one 3x. Hold on a second. I said this was my example. Now I could cross out x squared. This is different than this problem. I'm doing a whole new problem here. But now it is a factor, and so you can eliminate the x squareds. You'd be left with x plus 2 over x minus 3, and you cannot simplify the x's. The x is not a factor in the top, and it's not a factor in the bottom. So as soon as you see something being added or subtracted and not multiplied, you cannot simplify any further than that. Okay, that's it.